Today we're going to be learning about graphing inequalities on a number line. When we're trying to graph an inequality, we always want to read the inequality starting with the variable. So if we see an expression like this, we're going to switch it around and we're going to read it, instead of 2 is less than x, we're going to read it as x is greater than 2. Notice that when I changed the position of the x and the 2, I also changed the position changed the direction of the inequality sign to keep the inequality the same. So 2 is less than x is the same as x is greater than 2. And when you're trying to graph an inequality, you always want to read it starting with the variable. Okay, let's talk about some of the symbols that we're going to be using on our graph. When we see a less than sign, we're going to use an open circle, and we'll talk in a minute about what that means. And we're going to shade to the left, because the smaller values on the number line are always to the left of 0. If we are graphing a less than or equal to, we're going to graph a closed circle. We call this closed because it's shaded in. And we're going to shade also to the left because it is still less than. So the smaller numbers on the number line are going to be located to the left. If we're graphing a greater than, we're going to use an open circle. And we're going to shade to the right, because larger numbers on the number line are located to the right. When we are graphing a greater than or equal to, we'll have a closed circle, and we will shade right again. So let's just move down and do some examples. Okay, in example 1, we want to graph x is greater than or equal to 4. So let's just draw a number line here. We'll do 0, 1, 2, 3, and 4. Since we have a greater than or equal to sign, we're going to use a closed circle. And we're going to put that closed circle right on the 4, because this is where the graph starts. And now we're graphing all the numbers that are greater than or equal to 4, so we want to shade to the right, because the larger numbers are to the right on the number line. And a good rule of thumb is that if you, and you can do this if you have written the inequality with the variable first, is that whatever direction the inequality is pointing to, that's the direction we're going to shade. If you think of the inequality kind of like an arrow, it's pointing to the right, so we're going to shade to the right on the number line. But that only works if you have written the inequality with the variable first, starting with the variable. Okay, so now let's graph k is less than negative 2. Okay, here's our number line. So for a less than, we're going to use an open circle on -2. What this means is that -2 is not included in the solution because k is less than -2 but not equal to -2. In our first example, we put a closed circle because x was greater than or equal to 4. So that meant that the 4 was included in the solution set because it could be equal to 4. Okay, so let's talk about which direction we're going to shade here. K is less than -2, so we're going to shade to the left because the numbers that are smaller than -2 are to the left on the number line. And again, if you've written the variable first, then you can shade in the direction that the inequality sign is pointing, so to speak. Okay, so now in example 3, we have an inequality where the number comes first. We have 3 is less than m. So we're going to switch around this inequality to put the variable first before we graph it. So 3 is less than m becomes m is greater than 3. Okay, so it is a greater than, so we use an open circle to show that 3 is not included in the solution set. The inequality is never equal to 3. And then we're going to shade to the right because the numbers greater than 3 are to the right on the number line. So let's talk about what some of the symbols or the things that we're seeing on the graph mean. The shading. The shading represents the solutions to the inequality. Or the values that make the inequality true. And I'm going to abbreviate inequality because I'm running out of space a little bit. Okay, so the shading represents the solutions to the inequality. They're the numbers or the values that make the inequality true. Okay, so if we go back to our graph, the shading represents the solution set of the inequality. All of these numbers to the right of 3, when we put them into the inequality, would make it true. So let's pick a number that's to the right of 3, well 4, and let's replace the m with 4. So 4 is greater than 3. That is true. Okay, let's pick another number that's to the right of 3. Way out here would be 10. So 10 is greater than 3. Yes, that is true. Now notice if we pick a number that is to the left of 3, let's pick 0. Replace m with 0. 0 is greater than 3. Well, no, that's not a true statement. 0 is less than 3, so this would be false. So notice how the values in the shaded area make the inequality true. Okay, let's go back and talk about our closed circle and our open circle. So the closed circle means that the number is included in the solution. The open circle means that the number that the circle is on is not included in the solution. Okay, let's go on to talking about compound inequalities. Compound inequalities are when we have more than one inequality combined together. So here we have x is greater than 2 and x is less than 6. So the first thing that we want to do is we just want to combine this into one inequality. So I'm going to put the x in the middle, and I'm going to start with the smallest number, which is the 2, and end with the largest number, which is the 6. And then I'm going to put my greater than or less than signs in. Well, x is greater than 2. So x is greater than 2. And x is less than 6. So now let's graph this on the number line and see what that would look like. So we'll get our numbers labeled. Okay, so the endpoints are going to be 2 and 6. And what kind of circle are we going to put at the 2 and the 6? Well, that depends on if 2 and 6 are included in the solution. Since there's no equal to in our inequality, we know they're not included, so we'll put an open circle. Okay. So now x is greater than 2, so we want to shade to the right of 2. And x is less than 6, so we want to shade to the left of 6. So that would be this area in here that we're going to shade. So any of the numbers in between 2 and 6 would make the inequality true. Okay, let's do example 2. Here we have x is greater than or equal to 3 and x is less than or equal to 8. So let's first combine that into one inequality. Our variable goes in the middle, our smallest number goes on the left, our largest number goes on the right. So x is greater than or equal to 3. So x is greater than or equal to 3. X is less than or equal to 8. So as we're drawing the graph, I want you guys to think about how this graph is going to be different from the one above. Notice that our inequality has equal signs in it this time. So what type of circle will we put on the 3 and the 8? Well, we're going to use closed circles because 3 and 8 are included in the solution. The inequality can be equal to 3 and 8. So we'll put closed circles there. So now we want to graph everything greater than or equal to 3. So that would be to the right of 3. We want to graph everything less than or equal to 8. So that would be to the left of 8. So we're graphing in between the two numbers. So notice that with an and, in order for the inequality to be true, the number has to meet both of the requirements. The number has to be greater than or equal to 3, and it has to be less than or equal to 8. Another type of compound inequality is an or. So we're going to see how that's different than an and. So x is less than 2 or x is greater than 6. We actually cannot combine these into one inequality. And let me show you why. Let's try to put the x in the middle and the 2 on one end and the 6 on the other end, like we did up here with the and. Now here we have x is less than 2. Or x is greater than 6. So you notice how when we try to write the compound inequality, that the symbols do not turn out correctly. So we're not going to try to combine those into one inequality. An OR does not get combined into one inequality. And it'll make a little bit more sense. An OR does not get combined into one inequality, and it'll make a little bit more sense when we graph it here. Okay, so let's try to graph this on the number line. Okay, so we want to graph x is less than 2. What type of circle do we need on the 2? We need an open circle because 2 is not included in the solution. So now we're going to graph to the left of 2 because all of the values in the solution set are less than 2. Okay, now we're going to graph x is greater than 6. So open circle at 6 because 6 is not included in the solution. X is greater than 6, so we're going to shade to the right of 6 because the larger numbers are to the right of 6. So notice how here, instead of the shading being between the two numbers, it's on the other side of the two numbers. So is it possible to have a number that is both less than 2 and greater than 6? No, it's not, because it's either on this part of the number line or it's on that part of the number line. So that's why we use an OR inequality here, because the number cannot satisfy both inequalities at the same time. It has to be one or the other. Okay, let's graph our last inequality. So we want to graph x is less than or equal to -3 or x is greater than 1. -2, -1, 0, and 1. So x is less than or equal to -3. The equal to tells us that -3 can be included in the solution set. So we put a closed circle there. And x is less than or equal to -3, so we shade to the left. X is greater than 1. Since there is no equal to included in the inequality, we know that the 1 cannot be included in the solution set. So now we're going to graph x is greater than 1, so we shade to the right of 1. So notice again how a number cannot be in both solution sets at the same time, or in both shaded areas at the same time. So that's why this inequality has to be an OR instead of an AND, because a number can only be less than or equal to -3 or greater than 1. It cannot be both at the same time. Okay, that's all for this lesson.